Hello everyone. So in this video I'll be explaining binary search, like everything that you should know about the binary search, what binary search is and how to implement it, and how to implement binary search in CP problems. I'll not talk about those lead code medium level problems. I'll be explaining some good problems on off code forces. So this is the first video and this will be the basic video of binary search, like the basic algorithm of binary search. And in the further videos I'll be talking about the advanced binary search, like binary search on answer, and there I'll be talking about the monotonic function, that like what monotonic function is, what is monotonicity, and how binary search on answer works, and how to come up with an intuition to apply binary search on any given problem. Okay, so let's begin. This is a very beginner friendly video. Okay, so if someone is starting their journey in the competitive programming and they want to learn about binary search, then this will be helpful for them. So first of all, let's talk what binary search is. So binary search is as the name suggests, it is a searching algorithm which helps us to find an element in a given search space in a very efficient manner. Let's suppose we have given some numbers and binary search is applied when the array is sorted. Okay, when our search space is sorted basically. So let's suppose we have been given this array, some given set of numbers, and let's suppose we come up with a problem like we have to search in numbers that whether it is present in the given array or not. Let's suppose it is, the number given is 6. We are searching for 6, that whether 6 is present in our given array or not. So what we will do? So talking naively, what we can do, we will iterate over all the elements, like we will start from the first element and we will go up till last element, and we will compare each element with our given target. And if somewhere we will find that yes, this number is equals to our target, then we'll simply return yes, or whatever we have to use this number, we should do that. Okay, let's suppose we have to just return yes, that yes, we have found that number given target in our given array, then we will return yes. But what is the time complexity of this algorithm? This is a linear search, that we are moving through all the elements and we will finding our given target. So the time complexity will be as we are traversing each element once. So the time complexity will be order of n here. But since we know that our given array is sorted, then can we use something to improve our time complexity? Can we take use of that our given array is sorted? Yes, we can do that. How? Let's suppose we will take 2 pointers here and here, and we will find our mid. Like here mid will be I think this, let's suppose this is the mid, and we will compare this with this number 6, and let's suppose that the mid element is smaller than the target. So can we say this surely that our given target will never be found on the left hand side? Why so? Because our array is sorted and all the elements on the left hand side will be definitely be smaller than the mid value, this value. Okay, so we can't find, so the searching in this space will be just a waste of time. So we will discard this portion and we will simply move our load to mid, or you can say mid is also not equal, so mid plus 1. Fine. Now our search space is reduced to half. Okay, first of all it was n, now it became n by 2. Okay, and we have to search in n by 2 elements only. Again we will find mid. Let's suppose this is the mid, this one is the mid. Okay, 4 by 2, 0, 1, 2, this is the mid, this one, and we are searching for 6, and now this element is greater than 6, and we can surely say that our given target will never be found on the right hand side, because the numbers on the right hand side will all the numbers will be greater than this value, and we can't find 6 on the right hand side, never. So what we have to do, we have to discard the right portion. Now our search space will become half of this, n by 4. Okay, and since the mid value is also not equals to the target, we will simply move to the high to mid minus 1. Okay, and again we will find mid. What will be the mid? Let's suppose the mid is this. Okay, and again we will compare this to our target. What is our target? 6. This number is smaller. What we can say? We can say that we will never find our target on the left hand side, so we have to move on the right hand side. So we'll move our pointer to right hand side. Okay, this. And now you can see that the left pointer has crossed the right pointer. This is the terminating condition. You have to stop here because we have traversed all the elements that are of use for us. Okay, and there will be condition that there will be time when 6 will become the mid, and there you have to return the mid value. Okay, and what will be the time complexity of this algorithm? As you can see that our search space is reducing by half, so at a time it will become n by n by n by 2, n by 4, then again it will become n by 8, n by 16, and so on. Okay, so I can say that in a general manner it will be n upon 2 to the power n. Okay, fine, and let's suppose this is k. So rearranging the equations, I'll get k into 2 to the power n, and taking log value. Okay, taking log of n equals to nk log 2. Fine. So for traversing all the numbers, this is a constant value. So traversing all the n numbers, what will be the time required? Log n. Fine, because our search space is reducing by half every time. So to traverse all the elements in order to find the target value, the time that we will take is log of n, where n is the length of our search space. Okay, here the length was 1 2 3 4 7 8, so here the length was 8, so the time complexity to find 6 is log of 8. Okay, so in this manner we can apply binary search on a sorted array to efficiently find any given number in the search space. Okay, so to be more practical, let's try to implement the binary search on code forces. Here you have to first go to code forces, their edu section, and then you go to ITMO Academy pilot course. You have to enroll in that. Just enroll and go for it, and there you will find binary search here. Okay, here the binary search is. Go to step 1, practice. Here you will find the 4 basic problems of binary search. So I'll take the first one, where it is just the implementation of binary search that we have learned. Implement a binary search algorithm. So what the problem statement is saying, the first line contains the 2 integers n and k, the length of the array, and the input of queries. So what you have been given is 2 integers n and k, and secondly you have been given an array of length n, where you will be given some numbers of length n. After that you have been given some queries, and in each query you have been given a number, and you have to just print yes or no. Yes if the number is present in our given array, no if the number is not present in the given array. So as we are talking about the time complexity, what will be the time complexity of linear search if we apply linear search here? Order of n to traverse all the given elements. Order of q. Order of q we will take to traverse all the queries, and for each query you will traverse n times. So order of q cross n. This will be the time complexity if you apply linear search here. Okay, and the value of n and k is 10 to the power 5, so it will definitely give you a TLE. So this is how we can't apply linear search in this problem. So to optimize this, we will just apply binary search. Since the array is sorted here, it is mentioned that the array is sorted, so we can't optimize this one because we have to traverse 10 to the power 5 times in order to process all the q queries, and we can optimize this one to n to log n. Since we are traversing for each query n times, that will be done in log of n time. Okay, so for each query we will traverse only for log n time, and now the complexity will become q cross log n. Okay, so let's just simply code this up and see. Let me zoom it to make it more clear. So first line we have been given n and q. After that we have been given array, since the array is sorted, so we don't have to do anything with this. And now we have been given q queries, where each query contains a number. So we have taken the number as input, and we have to now just check that number is whether that number is present in our given array or not by doing the binary search. So I'll take low as 0 and high as n minus 1. Okay, and while low is less than equals high, I'll find mid. Fine. Now I have to check whether my, also I have to take a boolean that whether we have found that element or not. Found equals, initially it will be false. Now if I found array of mid equals target, then found will be set to true, and what do you have to else do? Yeah, we have to print yes in that condition, that yes, we have found that particular element in our given array, and simply break. Else, what if the array of mid is smaller than the target? As I have explained you, we have to shift low equals low to mid plus 1, because searching in the left hand side will be just a waste of time. And else, in else condition, there will be condition when the array of mid is greater than target, then in that condition we have to shift high to mid minus 1. Yeah, this is all about this. And if not found, if the element is not found, then print yes outside the loop. No, yeah, this is all about this problem. Infinite loop, how? Infinite. I've taken input target, low, high, this one, found false. Array of mid is less than target and shift low. Oh, low equals low plus 1, and this is going to infinite loop. Okay. No, yes, no, seems right. Okay, let's just submit and see whether we have implemented it correctly or not. Problem A, submit. Yeah, it is accepted, I think. Time limit exceeded on test 7. How? What the fuck? Low less than equals high. Low equals low plus. Oh, it should be mid. Yeah, it should be mid plus 1. My bad. Let's again submit. Yeah, it is okay. So this is the code for the first problem, as you can see here. So this was a very basic video of the basic binary search. In the next video, upcoming lectures, I'll be talking about the lower bound functions, lower bound, upper bound. Okay, and after that we will move to just advanced topics like advanced binary search, where we'll be talking about the binary search on answer and monotonicity, monotonic functions, all those things. Those are the things that mainly used in CP problems on the code forces. So we'll move to that very soon. Stay tuned, guys. Thank you for watching this video.